Welcome back, ladies and gentlemen. We have a really special session for you right now. 4 ways to use machine learning for your mobile applications, presented by the one and only Dennis Hill. Dennis is one of our rock star mobile development evangelists, and this is his last talk for AWS. He's moving on to the next stage in his career, so please give him a warm welcome, round of applause. Dennis.
Thank you. All right, Robert, let's take this away. So today's talk is about 4 ways for machine learning for mobile. So as a mobile developer, I wanted to start doing some really cool stuff with vision and text and all these really cool things. And then I found out how hard it was to actually do the machine learning part of it and break it down. And so this is kind of learning from the last year or two of working with our customers, working with other developers, working with our machine learning teams, and coming out with a way to, like, as practitioners, like as a mobile developer, how you can apply some of these machine learning tactics, like vision and some real time, some AR stuff. Our machines are really powerful these days, and they could do a lot of stuff. And when you see a lot of these machine learning talks, they're all about like the machines and the desktops and the GPUs. Well, we're all about like using it and actually making money from it. You know, taking a simple app, a simple chat app, and having communication back and forth with users and be able to do something like a text ahead, like you see in Gmail. Everybody uses that Gmail feature in there. And a text ahead, kind of prediction, just anything. Those are just the really common machine learning tactics that you'll see. In iOS and Android, you'll see when you upload photos, it now tags them with things other than geo, like certain people, family members, and you could tag them with names. Those are becoming normal machine learning offers that you're going to be applying in a mobile development scenario because it'll be common. Customers are going to ask for it. So no longer is it going to be like, ooh, we're doing machine learning. This is really cool. It's going to be a standard. Things are going to become normal for you. Things like a security camera. Anybody have a security camera at home that can predict family members and dogs? Anybody have that yet? You have it. Okay, good. That's going to become a norm. Back in the day, not even 2 years ago, there was, the standard security camera. You set it up, Wi-Fi camera. You set up motion detection, you set up the range and area, a big windstorm comes, trees, bushes, trigger all these alerts. The kids, the dog jumps on the couch, whatever it might be. Now, you deploy this package and you have the same camera, everything's done before you. You set up a family member, daughter, son, wife, husband, whatever it might be, and then you can trigger based on those family members or based on non-family members. So you can say, I want to trigger when the kids come home. Latchkey kids come home. I trigger my kids comes home. They know exactly who it is. Or if a mailman comes to the door and I don't recognize this family member, then alert. Alert me at work, or alert my wife, whatever it might be. So you have more control, more granularity, and that's going to become norm. And all it is a simple machine learning model on that device that has learned from 4, 5, 6, 10 family members, whatever it might be, and a dog. So you could say, okay, the dog could run in and out of the door, outside of the lawn, pooping on the lawn. It doesn't matter. You can just say, okay, great, that's my dog. If another dog pulls up on your lawn and takes a dump, then you want to be alerted. Then you can take a picture of it and send it to a neighbor. I mean, really simple stuff like that. That's going to become normal for that. So security camera developers are all going to be doing that same thing. If anybody's ever seen Deep Lens, our Amazon Deep Lens that we have, it's a really similar process where it'll take it and do machine learning, send some things in there, train a model, and then use it on the device, on the desktop or wherever. So today, I want to talk about 2 things about machine learning. I want to divide it in 2 parts. One is the training part, where you take a bunch of data, anything from flowers, text, anything visual that you want to take in, and you train a model by giving it just a bunch of data. And then once that model's trained, the second part is inference, so your prediction. So you're taking a picture of a lot of flowers, and you're saying, here's 20 pictures of daisies, here's 25 pictures or 50 pictures of tulips, right? And the model knows what a tulip is, it knows what a daisy looks like, and then you go and take pictures in the wild, and that model's trained to look at tulips or daisies or whatever flower it is, or unknown, and you simply take a picture, you send it to that model, and that model tells you a percentage of what it thinks it's going to be a daisy or thinks it's going to be a tulip. So that's kind of the basics of it. So I'm not going to talk about the machine learning part because even though it's one of the most difficult parts, the simple part that we want to worry about is getting that data and answering questions with that model. And the 4 ways I'm going to talk about is, as a mobile developer, we have the power of either taking that model that I just talked about, putting it on the device so we can be completely offline, secure, whatever it might be, and then we have options of you in AR and real time with that model on the device itself. And then there's the part where maybe the model's too large, we want to host it behind an API, or we want to train it in the cloud and move it elsewhere. So there's the 4 ways I want to talk about. Also using some of the frameworks that are built into these devices these days, some of the speech things I'll talk about. And I have 4 demos to run, so I'm kind of excited about that because we have Wi-Fi today. Yesterday we didn't. So hopefully we'll be able to show you some like real examples of what it means to like call a managed API with Amazon Lex or Amazon Translate. You know, these are simple services that you can call with a simple API and then get information back if you needed to. So as we go through, I just want to think about your application, whether you need to have it be online all the time, offline, you need security, whatever it might be. Think about that approach, and then think about the different options for connecting it to into the cloud, or breaking out and bringing the model onto the device itself. So we'll talk about the first one. And then you can go in any order, but I would always like to try the first one. There's a lot of great managed API services with Amazon right now. So we got Lex, we got Poly, Recognition. I'll do a demo of Recognition real quick. Transcribe, Translate, and I do also have a demo of Translate. Let's talk about Recognition for a minute. Recognition is simple video or photo recognition where you simply just send it a photo and it tells you like if it's outdoors, if there's a chair, if it's sunset, if there's sand, if there's people. It'll tell you the age of that person. Is that person facial hair? Is that bald? Whatever it might be. You can get that information out there. So think about it, as a mobile developer, you're creating just a file share app, right? And those users are uploading files in there, and you can automatically send those to Recognition and index those on the fly and then get back. And then all of a sudden you have this nice app where they can go and search and say, show me all the beach scenes. Show me all scenes with just females in it. Just show me a scene of just me in it. So all these things are capable of simply taking that image as the user uploads it and sending it to Recognition. Just a simple API call. Nothing hosted, you pay for what you get, pay for what you use, and that's pretty much it. Same thing for Amazon Translate. So you simply just speak into the phone and you're sending text to the API and saying, I want this English text translated to English or to French or German or Spanish, whatever language you want. There's a model for that, and it'll translate it, bring you back that translated text, and then I could do whatever I want with, read it back, or I could send it to Poly, and then Poly just speaks out that text that I just sent it. So I could, let's say I do French, I could say, speaking in English, sends the text over to translate to French. French text comes back, then I send it to Poly, and I have a Poly personnel that'll speak out in a computer voice, and I'll show you what the demo looks like. So those are examples of using a managed API service from your device that's capable now, and then you just pay for what you use. So there's nothing hosted there, no models to train or anything. So it's very powerful. So always try that first if that works for you. So I'm going to give you an example. Recognition. They have several services. They have face match. They have the data API where you can pull in the different the chair and the scenery and all that. But they also have a celebrity recognition. So where you could take a picture of a celebrity and you could send it to Recognition. It'll tell you if it's a celebrity. If it is, it'll give you that name of the celebrity. I said, okay, that's great. A little niche, but what I want to do is show you a demo of that, because what it talks about is that model. So what Amazon's done is train behind the scenes. They've taken thousands, we don't even know how many. We don't know how many celebrities or what celebrities are in that list. But they've created this model that says if I send them an image, they're going to come back and tell me if that's in the list or not, or in that model. So I don't have to do any training of anything. It's a built, pre-trained model that is managed by Amazon Web Services, and I just send it through a simple API. Now the idea here is, if you want to take that model and the celebrities aren't good enough for you, if you want personnel, like let's say I want all Amazon employees, and I want to take a picture, I'd have to train a model specifically, a custom model, and then I would either put it on the device or put it behind an API, just like Recognition would do. So that's how I'm kind of narrowing it down. So think about any of these managed services. All they are is just simple models that have been trained and provide prediction based on an API or sending an image or sending text, whatever it might be. So when I show you that, that's what we're doing. We're just typically taking that information and applying it. So if there's anything that's not provided there, like let's say Translate has a language that's not in there. Like Hindi was just recently released, and before it was like, oh, we want Hindi, we would have to go and train our own model or buy a model from somebody else who built that, and then either put it on the device itself. So then we'll talk about some of the different areas of machine learning when we talk about training in the cloud and then deploying it to the device, which is number 3. That's a really great one because you can actually take, let's say we were to take that recognition model, right, the celebrity model, and we were to pull it out of the API and put it on the device. Let's say it's 2 gigs, way too big, right? Well, we'll put it on their device anyway. And now at this point, a whole new opportunity exists now because we have this device that has the model that can identify tens of thousands of celebrities, and we don't need to make a single API call. And we could do it real time because we can go 30 frames per second into a model that's on our device and instantly determine if there's a celebrity in this room. So in other words, we take that celebrity model. If there's a celebrity in this room, I could simply scan this room and immediately identify the celebrity in real time. It'd pop up and say that's a celebrity because it's constantly sending those images back in 20, 30 frames per second. Whereas if I wanted to scan this room with recognition right now with an API, I would have to go and click, click, click. It's about 100 pictures at a time. I could go, and about a few minutes, 5 minutes later, I could have the information back and it'll tell me if there's a celebrity. So that's the value of getting that model and putting it on the edge, they call it, on the device itself, completely offline. One of the other advantages is, if anybody ever used Google Translate, now Google Translate's awesome, right? So you go in there, talk, and you can translate an app, but then you have to be connected. So I was in Portugal last year for Web Summit. I'm talking on my phone. There's a little bit of delay. I have a U.S. carrier, so it's like, roaming, and I don't want to use my carrier, right? So I'm in a cafe, and then Google pops up and says, do you want to download this model? And I'm like, I kind of knew what they were talking about. I was like, this is perfect. So what they're saying is, instead of making an API call every time I want to translate to Portuguese, they're allowing me to download this model, which is, again, another trained model of celebrities, whatever it is. This model is downloaded onto my device in the cafe, and now I'm walking around for 3 days just translating in Portuguese in real time, literally no delay. As soon as I finish, done, it's sending it back. It's sending right to that model on the device, completely offline. I can be in airplane mode. I can be translating on the airplane if I wanted to in different languages. So that's the power of having the model on the device itself and then taking it out. So really, it's all about that model and providing prediction. And that's all it is with the images. And then number 4, we'll talk about in a little more depth, is using the vision framework or using a speech API. And I'll talk about a couple of those examples. You can utilize a lot of those things on the device itself without making any API calls. So it costs you a lot less. So imagine there's a few companies out there that provide a lot of them that provide AI. There's one like Face++, if anybody's ever used it. They provide facial recognition, they provide facial mapping, they do a lot of different things, facial detection, whatever. A lot of that is already built into our mobile devices, Android and iOS. And I'll show you what that looks like because you can take all that information completely offline in real time and look at it and then decide what to do, whether you want to take that maps to a different data set or whatever it might be. We've all seen the Snapchat stuff where it's coming in like where it changes your male to female and then changes the googly eyes. All that is using that real-time eye maps right there in that picture where they're moving in real time and they're constantly doing the style transfer in real time on the device because they have the model there. So then anything can be sent back to the API, but it's all real time, so it's costing them nothing. They built the model, put it on there, so they don't have to make these additional API calls because they're using the built-in framework that's available to identify the faces, the eye gaze, the movement, and you'll see when I demonstrate it, you'll see eye movements, eyebrows, mouth, everything, and even tongue detection if you wanted it. And if you saw that last year, the tongue detection with Apple, and now you can move your tongue and it'll know exactly what location it is. So, you could actually navigate your apps with your tongue if you wanted to. So those are the 4 ways we're talking about, just ways of using machine learning in a different way and taking different approaches depending on whether you want it completely offline. Like there's some scenarios where we have cocoa plantations or banana plantations in the farm. They have to take pictures. There's a model that's built by scientists that says, if you take a picture, send me a picture of the plants in their current stage, it'll tell you if they're diseased or not, or what stage they're in of the disease. But they're in the middle of like Colombia, they're in Brazil. They don't have a lot of connectivity in the field. They had to go to a cafe or something to get the model, But then all the pictures taken, they continuously take these pictures throughout the day of these farms, and they can determine if anything's diseased, and then immediately go back, get connected, and then contact the scientists and the lab back at the home, and then get results in there. So that's a good example of completely offline. Another good example of some of the phones in in China and India, a lot of phones aren't actually connected all the time. So you want to be able to allow them to go to the cafe and download this app or download the model and provide it offline if you can. And a lot of times for the custom one, where you want to host the model, sometimes those models are massive. Like I don't even know how big the celebrity one is, but the more accurate, the larger the model is. And we're going to see in the next year or two, a lot of these cloud providers are jumping in and trying to figure out algorithms, compression algorithms, to compress these models to a size that's very accurate and we're on the device itself. So look out for that, because I'm hoping for that, because then we'll be able to put everything on the cloud, and then anything that's not in there, we can go real time and call APIs. Like a real time stock market ticker would be a good example of having that model hosted somewhere else. Another good example of, because it's more real time, it's training every few seconds. Another example would be if you wanted to connect to that same model from different platforms, like let's say IoT, the refrigerator, the iPhone, the Android, all of those can connect into that same approach in there. Okay, so we talked about a little bit the machine learning, so go check those out. Check out the API-driven services like Lex and Poly. I'm going to bypass Poly for one because I have the speech recognition framework on iOS for me to try. And then I'm going to do demonstrate translate. So let's go through 2 demonstrations real quick just so you can see what that looks like. So I'm going to end the show. Show's over. And I'm going to run through here. So first one, I'm going to do a recognition. Remember I talked about the celebrity, right? So I built the app that simply takes an API, and I just send an image directly to recognition, and then it comes back and says if it's celebrity or not. Now this used to be a celebrity, and somehow maybe he took his name off, so I'll take a picture of it. So the idea here, we're going to take a picture of, let's see, I got a demo folder here. Okay, so these are 2 celebrities. Use the photo. And oh. Did it come back yet? Oh, there you go. See, I was hiding the phone. So it pulled up David Beckham and Jude Law. These are supposed to be similar look-alike celebrities. That's why I chose it, so I could determine which one. It was a little bit slower than normal, but usually when you're walking around, it's like 1-2 seconds, and then you pull it out. What's nice about this is I can actually pull up images, multiple images of, oh no, I quit that out. Multiple images of celebrities, and it'll come back and pick all those up to like I think 100 possibly. Let me launch it again. I quit it. So I'm going to do one more demo of that so you can see the difference. Like I'm going to do this. I haven't actually ran this through yet, but this is the famous one you saw. Like what was it? Several years ago, they all got together and at the Oscars. So I'm going to do this real quick. I got to bring it back up so you can see it. Not me. I don't want you to see me. So again, this demonstrates the fact that we can just simply API call directly in there, and we only pay for whatever connection we'd make. But if we were to say, I don't want celebrities, I want X, I want Y, I want different celebrities, or I want the plantation workers or employees from Amazon, whatever it might be, those are options that you can do, but you'd have to customize the model and then put it behind an API. It's the same thing. So I'm going to take a picture of this one and see what happens. I doubt it'll get all of them, but say use photo, and then we'll see. Usually it's done about now, but it's connected to slow Wi-Fi, and we'll see. Hopefully it doesn't crash on me. There you go. And then again, if I clicked on like Jessica Alba, and it'll pull up IMDb. So that's the idea. So one of the advantages is we have the simple API, but if we were to pull this model out, right, if we had this option, we'd pull the model out on the device, And then we go with option 3, which is the model on device, completely offline. Imagine we're at the red carpet, Rodeo Drive, and I'm walking down the street. This is going to send images directly to the model on the device in near real time. So not only are we seeing these names across their face, I'll be like red carpet, and be like, oh, Mila Kunis, oh, yep, Jude Law. I mean, you could just do it in real time. So you could be like standing there and actually identify these celebrities in near real time. Do whatever you want with it. Imagine police force having something like this where they have the model of known suspects in that area, let's say the top 100 or top 2,000. Have it on their camera. They're walking around, eating their donut, and it's identifying as you're just sitting there walking by, and the images are being captured into that model. Remember, that model is just whatever you want to make it of, and it's instead of celebrities, in this case, it's wanted, the most wanted, or in that area. And that images, they'll go back to the model, and then it'll identify those folks in that model. So they can go back in large crowds, large events, whatever it might be. They can identify those and then pull that information and take action on it. So they drop the donut, pick up the glass cup of coffee, and then run after them, or whatever it is. And obviously there's false positives, whatever. We've seen all that with the recognition as well. But the thing is, you could set this on the mobile device however accurate you want. You say, I only want to show me 95% accuracy. If the model says 95% accurate, then show me that model. Then show me that celebrity. If it's not, then don't show me. So you can go as high as you want. You can say 50%, I'm good. It just depends on your use case. How, for law enforcement, 20% is probably good, right? Just set it 20%, we're good. And then we'll take action on the rest of it. But that gives you an idea what those things you can do when you have that model on the device and do some real-time stuff. Okay, so now the next one I want to show you is the speech one. So remember I talked about speech using the Amazon Translate. So for the voice, I'm taking my voice and it's transcribed into text, but I'm using the built-in API so I can be completely offline while I'm talking to it. And as soon as that text is done, then it calls the API to Amazon Translate, gets the text back for French, then I take that French text and send it back to Polly to speak back to me. And that's how it works. So we'll see how it works with this noise. The quick brown fox jumped over the lazy dog. Audio? Oh, hold on. We'll do French. All right, let's try it.
De snelle bruine vos
Dutch.
sprong over de luie hond.
Le renard brun rapide a sauté par-dessus le chien paresseux.
So let's try that again real quick. Because remember, it's real time, the voice to the text, and then as soon as I stop recording, it immediately sends the API call to translate. Welcome to the show. My name is Dennis. Thank you for coming.
Marché ou spectacle. Mon nom est Denis, merci d'être venu.
So see how that was? I mean, that was pretty fast on this Wi-Fi. That was really great. The text is going to come back just a split millisecond faster, and then the audio is coming back from Polly as a streamed MP3 directly from Polly. And again, that's another managed service that says, hey, I want a voice, a female voice or male voice with the French accent to come back and talk to me in that text that was translated from English to French. Does that make sense? So I'm calling it directly. And again, that's an API call. You'd have to be completely connected. But if I had an app and I just happened to have the French model, not the French model, but the French model, machine learning model, take the model onto the device, and then I could actually talk into it in real time, so convert the text, and then it would translate in real time. And then if I wanted to, I didn't necessarily have to do the voice thing. It's just kind of nice, because then you could just like hold it next to somebody and they don't have to read it. So you have that option. But I just wanted to show you that because you're using a combination of the communication with the device with the speech API, which if we weren't to use that, we could call like Lex, which is another one of our services where it says it transcribes, takes your voice, converts it to text in a Lambda function, and then sends it out to translate. So we've just saved an API call. And we are real time. So everything we could correct it if we wanted to. Or imagine having this turned on and streaming. Again, with real time, we could have this connected, and every minute it'll reset. We could be talking to it, and it could be sending stuff back inside the app if you want, and looking for keywords. So it's the same process if somebody were having an app and I was doing a selfie and I said, we were just talking about cheese, takes a picture, because it's sitting there listening, looking for that cheese keyword, and then it just takes a picture, calls the API on the app and takes a picture. So those kind of things are possible, really nice, because you can actually control your devices with your voice using just a simple speech API. So does that make sense? When you want to go use the managed APIs, go for it. But if it doesn't work and you don't want some other language that's not supported by Translate, or it's not working the way you want, or you want to put it on the device, then you train your own. But the idea is we're hiding that part where they're training the model, which isn't the easy part. But just as you're going through these steps of developing or trying to figure out the next project, just remember that you need a model to answer these questions that you're trying to solve, like whether it's an image, whether it's a celebrity, whether it's a most wanted, whatever it might be. And again, the same thing for text. If you're looking for text ahead, like if for lexicon or like images or trademark names, you can also put a small model on your device in there. And if you have certain keywords for your business, then it'll automatically pick it up. Like if somebody's chatting or talking on your phone, on your app, and they say Amazon Web Services, it may come back and abbreviate it and put AWS. So you could do that, do aliases, or if I'm running, it'll do running shoe or runner or something like that. So it'll break it out and tokenize it if you wanted to. So there's a lot of ways, and that's what a lot of the iOS devices and the Android devices are doing right now, and what Google does with Gmail. Okay, so let's move back to here, and we'll pull back the slides, and then we'll do a couple more demos at the end. Okay, so that was there, and there's a couple links. I want to take some pictures of it just in case the demos failed, which luckily they didn't. Okay, and so this is number 2. Build and train in the cloud, and then host the model behind the API. So I use Amazon SageMaker, but it could be trained in whatever process you want, in whatever cloud provider, it doesn't really matter. And we talk about the cloud. When we talk about training, almost never talking about training a model on the device, even though some people say, oh, I can train a model on device. Yeah, it's possible, but not realistic. And it's very, 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 very small percentage of devices or capability. So when we talk about training, we talk about training on the cloud, or possibly training on a nice desktop, like a nice Mac that uses CreateML or something like that. So again, you're feeding it a bunch of images of flowers or dogs, or whatever, and you're training that model. And then you could actually test it offline, test it with other dogs. And the idea is, when you're training models, you're training on all the different sides. So more data, the better. And then when you test it, you want to test it on non-trained data. So if you train it on like 7 or 8 Cocker Spaniels, when you test it on 2 Cocker Spaniels, make sure that those aren't the 2 Cocker Spaniels that you're trained on. Obviously, they're like, yeah, I see, I know what that is, right? So you're training it like a little kid. You're just showing it pictures constantly, or images or sentiment, whatever it is, and you're just training that model. And I think we're going to see, again, like the compression we talked about, we're going to see a lot of improvement in where we just, as practitioners, we're going to be able to send a bunch of images, send text, and say, I want to answer this question. And then the data scientists or the APIs behind the scenes will give us a model, and that'll be it. So those will be nice to have, because then we'll be able to just not even worry about that training model. I don't know if that time will come anytime soon, but that's the idea of being able to deploy it to the device. So then this point is deploy the model to a predictive endpoint, invoke the HTTPS endpoint. So what this is doing is taking that, remember we talked about there the model is too large for the device, or we want to train the model every 5 seconds or every minute. Let's say we're a ticker stock and we're doing business modeling. And so if we want this real-time modeling, we're going to want to keep it in the cloud, continuously train it, and then we have our mobile app or IoT devices connect into that HTTP endpoint that has the model behind the scenes. And that's exactly how we would do, that's how we do recognition, that's how we do all the other services. All recognition is doing is putting an API gateway in front of that model and saying, okay, send me an image. And you would do the same thing. You'd say, okay, I'll train my own model, put it here, put it behind an API, and then do whatever you want with it. And you could resell it, whatever it might be, or you could do whatever. So that's the idea. Some of these devices can't hold a large model. So again, another reason for hosting it behind the cloud and giving it an API. Now again, when you train a model, the same model could be behind the API or on the device. It's the same model, everything the same accuracy. you're just going to do a conversion script from to Android or iOS with a Core ML, which I'll show you an image of that. So that's pretty much it. So it doesn't matter whether you're doing TensorFlow or MXNet, whatever it is to train that model. It doesn't matter. Just give me that model. I'll convert it to Core ML or convert it to TensorFlow Lite for Android, or not, and just leave it TensorFlow and host it behind the API. Again, same accuracy. Everything's the same. You've trained that model, and you've put it on the device. So some of the use case requirements: network is available, always reliable, always on. Again, that would be really tough for those devices that aren't always connected, because then it just doesn't make any sense. Like the speech translate, you'd kind of want a little bit of both. And models can't be easily deployed to the mobile. Prediction activity must be centralized. So again, you want to centralize it for all those different platforms that are connecting to that endpoint. Okay, so the fun part. Number 3, train a model using SageMaker. Well, same thing, right? We just trained one. Okay, we'll use that one. But now we've decided, okay, we want to go offline, or we want to have that capability. Again, we can kind of a mix and match. We could have a model in the cloud and have the model on device if we wanted to, and make that call. So again, a lot of times you want to just save an API call. So you want, if that model's small enough, let's get it on the device and use it, and then we can decide what to do and make API calls. So again, take that TensorFlow, that MXNet model, whatever it is, or if they were to let us export the celebrity one, we would take that model, convert it to Core ML or TensorFlow Lite for Android. Again, you can use TensorFlow Lite for iOS if anybody's ever done that. I like to use the best tool for the job, and I'm a huge proponent of doing that, because the Core ML is specific for that device and the platform, and it goes really well with Vision Framework and the speech. And I'll talk about that in the demo as well. And same thing for TensorFlow Lite. TensorFlow Lite was built for Android, and specifically for Android, but they ported it through iOS, which they don't have control of that hardware and operating system running in there, so it doesn't perform as well. So again, and it's not that big of a deal, because remember, for Android and iOS, it's the same model that's trained in the cloud that's provided both of those. It just means you're scripted into a different format. That's it. But should be the same accuracy, same format you're sending it. Okay, so some of the advantages: low latency, we got offline capable, always available, and privacy. These are just one of the many options that we have on the device when we're running the model on the device itself. So you got real-time object detection is one of those options that allow you to take a model. So I'm going to do a quick demo of a model that's trained on, like, let's say 1,000 everyday objects. The one I have isn't super accurate. It's the Inception V3, if anybody's familiar with the ResNet and a bunch of different models. So data scientists have used this, and it's like a 90 meg file. It's a model that's been trained on thousands of everyday objects, multiple versions of them, and then we apply that model, put it on the device, and now I can take pictures. But imagine that. It's so boring, right? You take pictures of it, and you go click, click, oh, that's a chair, that's this. It just doesn't work. So now we got these mobile devices. Everything should be real time. If you have that model on the device, everything should be real time. And so I'll run through a demo real quick of two examples of using that model on the device and taking advantage of that real time. Remember, talking about celebrity. If we have that model celebrity and we were to train it, we would have that real time identification of the celebrities with their name on their faces, and we can actually click on their face and connect in there. So the one demo I want to do, let's see if it works, is, so this is just a simple model that's, again, that Inception V3, 90 megs, and I'm using AR with it. So it's going to go and track in there, and it should start picking up everyday objects if it works well. And so right now it's just sending images back and forth to that model, and should pick up and display if it's working. And we'll be able to see the frames per second and everything else. Let me reboot that. We should see frames per second. We should see a few other things when it initializes. Tracking normal. Okay, let's try that again. Oh, there we go. So see that on the upper left? See how I'm moving it around, and the accuracy, the confidence changes. Remember I talked about that 60 to 50, 70%? I could say, show me, right now it's just displaying everything, but I would only show Notebook if that was above 70% or 75%. But what this is also demonstrating is the real-time aspect of this, right? So as I'm moving around, it's constantly sending images to this model and trying to predict, I wish I had some other stuff, it's trying to predict exactly what information is out there, motor scooter. And sometimes, like, if it look at me, it's gonna, yesterday I think it said I was wearing a shower cap or something. So hopefully it doesn't do it. Ping pong ball. Kidding me. I don't make this up. I'm telling you. Yesterday it was a neck brace, and then I had, so obviously we got to work on this. Who made these things? But just get the idea, this is real time, and if I was to scan, this is using the AR kit, a combination, so that you can go and scan things. And you've seen it before, like in national park apps or stars align. All of that's using some kind of like, location and an AR kit with a little bit of machine learning in there at the same time. So imagine that being the celebrity, or being like the police cam walking around, or a dash cam. A lot of folks have dash cams in their car now. Imagine the data that you can collect and identify cars and capture it. Like if you wanted to get a picture of license plates, and you could send it back to your own server if you wanted to, and say, hey, I followed this car 3 times this week. And I mean, it'd be totally useless, but the idea is you can do that now. So that's a really nice way to kind of demonstrate the capability of getting that model on the device. And remember, I could be in airplane mode with that and be in real time and get that information in. And then it could start collecting the data, or it could do whatever. So imagine if we were in an office and we had identified all Amazon employees. And we're in the office, and every time somebody comes in, we have a camera. They come into the office, it identifies them as employee. And then it also could check and verify, okay, employee, are they on the list? Are they on the invite list? Like, let's say we have a high security meeting. Nope, not on the list, and then it beeps or does something. So something as similar as that we could put into all these meeting rooms with just a simple identification on the device. Doesn't have to make any API calls, except for when it says, okay, it knows it's an employee. Now let's go look at the calendar and make sure that name matches with the calendar event. Pretty simple. So those kind of things are really cool, because then you have this mobile device and you can carry it with you, and you can do all these really cool things. Now again, if you have a certain app, like we talked about the security app, we can be an app developer and have 1 million users, and each of those 1 million users could have their own model, right? In that case, we had the security camera. We could train the family members, the dog, and we can create their own model specific for that user if we wanted to. And we can go and make our own security system in their phone. So again, something like where you have your friends or family and you're taking a picture or selfies, and there's 3 or 4 family members or friends, and you're out playing around. Instead of like, oh, will you send me that picture? It can identify the pictures, and it knows the contacts of those faces. It can automatically send a text message or send it to your app that you created, and automatically share those images or those photos of your friends in real time. Well, it's kind of nice. So everybody gets the same image twice, or in real time, and then they could go ahead and delete it or not, or they could send it and share it, whatever they want, and then it's identified. So even taking a step further than what Facebook has done. So let's move on. I'll run, since I already got the demo up. I'm going to do one more thing with the offline. I'll show you what this looks like. Okay. So remember I was talking about the framework, the offline framework that identifies the facial and the movement. You see when you're taking a picture, there's that rectangle box or the square. That's machine learning, knowing that, oh, this is the face. If a dog goes in there, it probably won't pick up the dog because it's an object, it's not a human face. So the same thing you can take advantage of when you say start, I want to take a picture of myself, or actually this is the real-time one. I'll show you the other static one. This is the real-time one running the framework and showing you each of those spots that are actually done for you in real time. So imagine all those post-production folks that work for Twitch. They have to go in there and blur something out. If I drop my drawers right now, they're going to be in trouble, or I will be. My last day anyway, so I don't know. But you imagine that this is real time, so you could actually be streaming audio from your app, doing the 30-second or streaming to Twitter, and it automatically blur out eyeballs. It knows exactly where everything is at all times. I mean, I could fake it. Not only that, you see those little green eyes, those coming out of my eye when I move? That's eye gaze. So if anybody ever wants to do accessibility apps and scroll with your eyes, anybody use that Android feature? I always turn mine off because it's weird, but if you have a long scrolling app, you can use your eyes and just scroll up and down if you wanted to. So again, this is the built-in framework, completely offline, and then see, I faked it right there. But then you can map this, and this is what the Snapchat, a lot of those other social media apps are making millions of dollars off of simple API calls, and then putting googly eyes on top of your eyebrows, putting lipstick on a pig, that's it. And they're not making any API calls. And then send a little analytics to the cloud, you're spending $50 a month, making $1 million a week. So those are the kind of things that are really cool because you can take advantage of that information. Imagine streaming information and having to moderate this on the fly would be ridiculous. So this could be moderated from the device, and anything that didn't get caught on the device could be sent elsewhere. So I'm going to provide a streaming app. I want to make sure it's moderated through this information. And then it locked up. Okay. And then there is one more. Let's see, do I have another one? I think that's all you get. The other one just demonstrated a static version, which is kind of boring, but you take a picture and then I drew a line of the actual same points. But the idea is you could see everything. So you have control, and you could use all those API calls where the mouth is moving, the angle, all of it, and just put anything on top of that. And again, that's where I put the label of the celebrities. Notice that if I lined it up right and had the scale correct, the beginning of the text was on their nose. So if you have 4 people, 4 celebrities, and it has their name, the label will be right on their nose. Because I had the API call, and I knew exactly what that nose location was, those coordinates, and I was able to put it on there. So that's kind of cool, right? They just put all that stuff in, put it together completely offline, and then just take advantage of that. So again, depends on what scenario you have, whether you're offline, you need to be online all the time, and what kind of model you're trying to do. There's all those options. So let's run through. So I took a picture of, again, it noticed the keyboard, running shoe, whatever it might be. And again, same thing with flowers, roses, diseased plants. All of it is the same model, you just put on a device. And I could use the same technology. So as an app developer, I could say, all right, I got all this AR stuff and all this tagging. Let's just change the model. I'm going to go to a dog park, and now I'm going to identify 1,000 breeds of dogs and go, hey, what kind of dog is that? Oh, it's a Shar-Pei. Got it. Just simple by changing the model, and everything else is the same because I'm just sending an image directly to that model. It's just different. And celebrities, I go from dogs to celebrities, or celebrities and dogs if I wanted to. Okay, and I already showed you some of this, but again, try to utilize some of the vision framework that's available through through Apple or Android. And then also the option of natural language framework. So with this parts of speech tagging, so as you're talking through, I don't know if you noticed when it started to put commas and periods in there, and then it does tokenization. So again, you can actually take advantage of that and do search. So when you're doing search, a lot of it's tokenization. It's like I say, I'm running. It'll always tokenize it to run or run. And it'll send that run as a search criteria instead of sending running. And that's the way search works. That's how they can make it much faster. So they always tokenize those into little values. And then lemmatization and parts of it. But you can do that on the device itself. So if you were to talk, you could actually send those and say running. I could have it send a run instead of running, and then send it back to the server, do a quick search, or do a search on the device itself. So you're kind of taking advantage of a little bit of built-in language framework and parts of speech and tagging, and then send it out. Like if I said Amazon Web Services, is it going to get all of Amazon Web Services all spelled out correctly? Probably not. So I'll have something in there so it'll know exactly what that token looks like, and it has a figure like, okay, it sounds like Amazon Web Services, then send it out. So a lot of companies do that where they have unique names for running shoes, like if I have like the Adrenaline or the Beast. These are certain types of shoes or of Brooks shoes, and I could say, show me all the Beast shoes, and it'll say, okay, look at Beast instead of looking at like the normal, like what a Beast might be. So again, use the voice translate app. We did that, and then we demonstrated the real-time framework for vision. And again, this is the 4. So we're going to just do a recap of those and talk about 1, 2, 3, and 4. And that was pretty much it. That's the gist of it, trying to figure out exactly where you want your app. If you need it to be offline, you want to move the model in the cloud or on the device itself. And I can take any questions. We got how many more minutes? 5? 5, 10? Yeah, I got time for questions if anybody wants. Yeah.
Video. Is this on? Okay. So, can it detect the images from a running video on a frame and tell like whoever that celebrity? I'm I'm from a sports background.
Yeah.
So I'm just trying to see if I'm running a clip on some sports category, and a person or a user basically is pausing in a certain screen, and then can it detect like what the players within the screens are, and then go to their BIOS?
Yes, I mean you'd have to build that. That's not available now, but I think we're going to see that coming down the pipe, where we could either a combination of the real time and then send the analysis to recognition or your own custom model. So a good example is we saw that with World Cup. So World Cup, all the players aren't identified in recognition, but if you had a model of all World Cup players, then as you're moving through, you can get that information back from the video or the image itself. But you'd have to do the real time of the device, of the video itself.
One other question I have is like, if I'm reading like a text-based news, which is in English, but I want to get an audio commentary out of it in a different native language, is that something Amazon is currently capable of? Can I upload this text into some sort of cloud modeling and then can receive like a voice radio kind of thing in my native language?
Wait, you want the voice in your own native language?
So basically say like I have like an English text news. I want to upload this, and with a click button, can I translate this as a radio voice in my native language?
Yes. Yeah, well, if the language is supported, I don't know the native language, but yeah, if the language is supported, then you can actually send the text back or use Poly, which is the one that says, okay, native language, I got a male or female in that native language that'll speak that language text. Yes, and then back and forth. So yeah, you have that capability. And again, you'd have to build the model, which is a tough one, right, to build a language model. So hopefully you can use that managed API service to call.
Yeah, and you mentioned you were you work in sports, right? I also suggest checking out some of the work that the NFL streams have done with AWS. It's not quite real time, but it's very impressive in terms of what they could do near real time. So they'll have a live play, and then very shortly after, during the replay, they'll have all this intelligence and analysis overlaid on top of the feed. Just Google for NFL replay AWS.
Yeah, and Formula One is another one where they could actually, within seconds, they're going to predict who's going to take the lead, or if somebody's going to do a pass, or this turn's going to be a problem. They can predict that based on the data collected in real time.
I have a quick question from Twitch by Calderoon. He asks, the stuff that you built, is it available for Android as well?
Not mine. It is, some of it's available for Android. There is a speech one that I did. Then the same one as Adrian, my coworker, did for Android. So I could send, can I send a link through that?
Yeah.
Okay, we'll send a link out to that, yeah. But there's an Android version of the speech translation, but not the recognition one.
So just to be clear, Calderoon, we're making a distinction between whether the APIs are available and whether this demo app is available. I think, Dennis, you're saying that the demo app is not available, but the APIs are all available.
Absolutely, yeah. And one of the differences with Android and iOS is the Android devices, in a lot of cases, Android's the number one operating system in the world, right? So let's develop for Android. But the problem with Android is we have so much fragmentation, we have so many older devices out there with older operating systems that are managed by those carriers who haven't updated the OS. So when you go to do that TensorFlow Lite on the Android device, you've lost over 70% of the entire Android population. So think about that when you go to deploy the app and you say, oh, okay, I want this many users. You're going to start losing those users because they're not capable of even running the simplest inference or prediction on the app itself.
Hello, can you hear me?
Yeah.
Okay. I'm a traditional IT guy, try to learn AI, and I constantly confused by the term module. I understand databases and binaries, executables, but what is modules? I pick up different attributes from your talk, like the attributes can be big and small, can be downloaded. But can you explain what is modules? Is something I can understand?
Yeah, no, I can't. I mean, in my terms, I think of it as a brain, like sort of a database plus a file storage and everything. It's really just a brain because you've trained on all these different layers. And if you ever look at neural networks and this data scientist will show you all these different layers. And it's all in there, and it's just learning on all these images and putting them in different layers. And usually the ones that you really focus on are that last layer. So just think of it as a brain, a sponge that's absorbing all that data, and then you're sending it information that's been trained on. It says, I don't know what it is. And that's really all it is. So just think of it as a brain, as a binary connection, and then you connect into it with a string, and then you have a metadata and says, I want to send it images of JPEG, of PNGs, or I need to send it a stream of text, whatever it might be. So think of it as just sort of a, there's a definition for it, but that's how I would think of it as a brain.
So I can understand module as a executable plus the data set combined together, which is a knowledge.
Yeah.
Okay, so I can have modules for to identify specific person, or I can have another module to differentiate between cat and dog.
Yeah.
They are different modules.
Yeah. And you can have models passing to different things. So you have a model with flowers or not. So we're out of time. Thank you.
Thank you.
All right, thank you.